Okay, today's lesson is describing number patterns. So our objectives today are to use inductive reasoning and continuing number patterns. Okay, inductive reasoning is making conclusions based on patterns you observe. A conjecture is a conclusion you reach from that inductive reasoning. So kind of like a conjecture is, what is your answer? What do you think the answer might be? So, and then we're going to write rules for arithmetic sequences. Arithmetic sequences, there are two types of sequences we're going to learn today. We have what's called arithmetic sequences. Arithmetic sequences, that means you're going to add numbers. You can add negative numbers or you can add positive numbers. Am I adding by 2 each time? Am I adding by -3 each time? We do not subtract. Arithmetic is always about adding. So you're either adding a positive number to find out your answers or a negative number. Okay, then you have what's geometric. And that is my multiplication of it. Am I multiplying by 2? Or am I multiplying by a half? Or by a decimal? Now, so I'm not dividing by anything. I'm multiplying by a whole number. And if I need to divide in my head, you are doing a fraction or a decimal. That's how you find out your answer for geometric. So, some vocabulary. Inductive reasoning is making conclusions based on patterns you observed. My patterns, if I did 2, 4, 6, 8, what is my pattern here? I am doing what? I'm adding by 2. So that is my inductive reasoning. So my conclusion you reach by inductive reasoning is a conjecture. So me saying adding by 2 is my conjecture. A pattern is also called a sequence. So my sequence here is 2, 4, 6, 8 are even numbers. Okay, if I did 1, 3, 5, 7, those are odd numbers. My sequence are every other number. Each number in a sequence is a term of the sequence. And you form an arithmetic sequence by adding a fixed number to each previous term. And the fixed term is the common difference. Okay? I can commonly have a difference of a positive number or a negative number. So it just depends. So here are some, here's an arithmetic sequence rule. You have an, so the a function of n equals a plus n minus 1 times d. So I have all what you need to know about this one. We'll do this at the end of the lesson. So the nth term. So if I say I want to know what the 34th term of this sequence is, instead of going through each number to find it, you can just plug it into this number. They'll give you this information, and they should give you this information. All you would have to do is plug in what term I want you to look at. So let's do some work. Use inductive reasoning to describe each pattern, then find the next 2 terms. So, I need to put my pin on. I went to the wrong one and put my pin on there. Okay, I need to go from 2 to 5. What's a good way of doing it? If I'm adding, what am I going to add by? I'm going to add by 3. Now I have to see if it works for all of them. 5 plus 3 is 8. 8 plus 3 is 11. So that is my pattern. That's all the description I want from you guys. Another way to say it is add 3 to the previous term. Okay? Now it says find the next 2 numbers in each pattern. Now, so this is telling me this is going to be worth 3 points on this homework, on my notes. I don't know. They might ask for the next 3. You know, you never know. So if I'm going to add 3 to 11, it's going to be 14. And then add 3, it's going to be 17. So there are my other 2 numbers. Now, we'll start with adding on this one. 2 plus 2 equals 4. Does that work? 4 plus 2 equals 8? No. So it cannot be plus 2. So I know it's not going to be by adding. So let's do multiplying. 2 times what gets me 4? Well, times 2. So 4 times 2 equals 8. Oh, that works. 8 times 2 equals 16. So times 2 would be my pattern. Multiply 2 to the previous term. And then I'm going to multiply by 2. And multiply by 2. So that's going to be 32 and 64. Ooh, next one's going to be different. This one's not going to be a normal one. I do. So if I do add, it's plus 3. 4 plus 3 is 7. Nope, that doesn't work. Can't add. Let's see. Can I multiply? 1 times 4. 4 times 9 is not... 4 times 4 is not 9. Wow. So it can't be multiplying. So this is a little different. So you have to think of other math terms that happen. Well, I know 1 squared equals what? Equals 1. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. So how would you write this one? You would write square, consecutive integers. Now, consecutive integers means you go in order. Like if it's 1, 2, 3, 4 integers. That's a consecutive order. I'm doing it all next to each other. So the next numbers would be 5 squared and 6 squared. So my answers would be 25 and 36. All right, let's try D. Adding 2 plus what gets me negative 4? Well, plus negative 6. Negative 4 plus negative 6 gets me negative 10. Well, that doesn't work. So let's try it again. 2 times what gets me negative 4? Well, negative 2 does. So 2 times negative 4 times negative 2 is positive 8. Oh, that works. So negative times negative 2 is my answer for this one. So I'm going to times negative 2 and then times negative 2. So negative 16 times negative 2 is positive 32. And 32 times negative 2 is negative 64. When you're multiplying by a negative, it's going to be every other one. Every other one. Okay. Example 2. This is arithmetic. So you're going to be adding by something at all times. Adding. This is arithmetic. So, I'm adding negative 7 plus what is going to get me negative 3? Plus 4. Does that work? Negative 3 plus 4 equals 1. So it's plus 4 too. All right. And that's all you're finding on this one. So 17 to 13. I'm adding by 17 plus, I'm guessing it's negative because it's going down, plus negative 4. 13 plus negative 4 is 9. 5 plus negative 4 is, okay, so there's your answer to that one. Try C and D by yourself. Put me on pause, check it out, and see what you come up with. All right, so C I came up with, I added 12, and on D I added negative 5. Check and see where you might have gone wrong if you got them wrong. Okay, let's try the next one. All right, so example 3. It says, find the second, fifth, and ninth terms. Second, fifth, and ninth terms. Those are the numbers you're going to plug in for n. So instead of trying to find out all the sequences, you're just going to plug these three numbers in, and you'll have 3 different answers. So you're going to go A2, that's just telling me it's the second term, equals 32 plus 2 minus 1 times 2. And you're going to do that for all of these. So I plug them in. And so I'm just going to go to the right on each of these. I have 32 plus 2 minus 1 is 1 times negative 2. Okay, 32 plus 1 times negative 2 is negative 2. 30 plus negative 2 is 30. And there's your first answer. Then you do it here. 32 plus 4, because 5 minus 1 is 4, times negative 2 is, so it's going to be 32 plus negative 8 equals 624. Notice this last number, this negative 2, is telling me my number is going to go down instead of up. So all my numbers should go down at a certain rate, by negative 2 to be exact. So 32 plus 9 minus 1 is 8 times negative 2 equals 32 plus negative 16. And that should be 16. All right. So B. Same idea. Please fill in this part of it with same numbers for B. Put me on pause and write them out. Do that for A and C first. All right. If you could tell, on this one, I have a positive on the end, so that's telling me the numbers are going to go up. So I have negative 5 plus 1 times 3, that is negative 5 plus 3, which equals negative 2. And then I have negative 5 plus 4 times 3, that's 12. So negative 5 plus 12, that equals 7. Oh, my numbers are going up. Negative 5 plus 8 times 3 is 24. Negative 5 plus 24 equals 19. Please do C completely by yourself and check and see if the answers are correct. Here's your answers: 11.3, 26.3, and 38.3. Again, this number is telling me I'm going up in sequence, not down. All right. Check and see where you went wrong if you did the math wrong somewhere. Goodbye.